In this lesson, we're going to look at two more types of organic reactions, and those are hydrolysis and condensation. Condensation and hydrolysis are actually opposites of one another. If we look at the forward reaction here, we see two molecules coming together to form one molecule plus water. This is known as a condensation reaction. We're condensing those two molecules into the one larger molecule. Just like before, ation means to add, so we're adding these two molecules together. As we form the new product, what we see is that we need to find a water molecule in there to remove from the original molecules. And what we have is that an OH on one and an H on the other. By removing those, we are left with one oxygen, which then also bonds to the other molecule. Hydrolysis is the opposite, and so lysis means to break things apart, just like glycolysis is used to break down glucose. So hydrolysis means we add water and we break something apart. And that is represented in the reverse reaction. We add water and break this one larger molecule into two smaller molecules. So condensation occurs when two molecules form one molecule plus water. During the condensation reaction, we will remove an H and an OH and then bond the remaining pieces together. Remember that R represents rest of the molecule, so we see that in both of our reactants and in our product. And the difference between R and R prime is there just to indicate that these could be the same R group or they could be different R groups. Either one will work. So when we're looking at our two molecules that we're going to bring together, we see that we're going to lose the H from one of them and the OH from the other. What remains is a fragment that has RO and then the R prime piece. So now we're going to add a bond in there between the O and the R prime. Notice there is no carbon atom here because we have the R directly bonded to the O. This is also known as a dehydration reaction. Just as hydration is the addition of water, dehydration is the removal of water. And because we also form a water as a product, we call this a dehydration reaction. Hydrolysis occurs when water is added and breaks molecules apart. In this case, we see ROR, and again, the R and the R prime are just the rest of the molecules, that chain of carbons and hydrogens. We're adding a water, and we produce two other molecules as our products. The key is that we have to break it apart, and so sometimes students are confused as far as where to break the bond. What you want to look for is a carbon-oxygen, carbon-nitrogen, carbon-sulfur bond. That tends to be where the bonds will break. We will not break carbon-carbon bonds, and we will not break carbon-oxygen double bonds. Once we've broken it apart to get the fragments, we will add H to one part and OH to the other part. During these reactions, whenever we're adding or removing water, we always look at it as an H and an OH. So let's look at this molecule, and we're going to break it apart on this side with the RO between the O and the R prime. This will leave me with RO and R prime. I now need to add the water molecule in the form of H and OH to either side. And now we see we formed these two products. If you're wondering why we didn't break it on the other side between the R and the O, go ahead and do so. See if you get a different product. Remember, there's nothing special about whether the oxygen is in red or blue in our drawing. That was just for tracing purposes. As long as there's an O and an H, it's the same molecule. Let's look at some more examples of hydrolysis reactions to help you learn where to break these apart. In the first one, we have a C double bond O and a CO. In trying to figure out where to break it apart, we have two options, one of which is here, and the other is here. We're going to pick one, but in reality, you would get the same molecule regardless of which one you broke apart. I tend to look for the one between the C double bond O carbon and the oxygen. That tends to be the weakest point. So what we get is two carbons with a double bonded oxygen, and then an oxygen with two carbons. Now we have to add the water as H and OH. We're going to add the H to the oxygen atom because we don't see bonds forming between oxygen and oxygen. So if we added an OH to the fragment on the right, we'd have OOH, which doesn't really exist. So we're not going to do that. We're just going to add the hydrogen, and then we'll put the OH on the other fragment. Now we have our carboxylic acid and an alcohol that have formed from the hydrolysis of our ester. Now let's look at the next one. We have an amide group. Again, we need to see where it's going to break. So we're going to break it between the carbonyl carbon and the nitrogen. So we'll break it right there. And our fragments will be two carbons with a double bond O and NH attached to two carbons. Again, we're going to add our water as H and OH. And we're going to add the hydrogen to the nitrogen, because what we see is that we don't also, just like we didn't get the OOH, we also don't get an NOH bond. So we add a hydrogen there, and then we add our OH to the fragment on the left. Now we're going to look at the last one, and this one doesn't make it as clear as far as which one we're going to break between the carbon and the oxygen, because there's nothing that distinguishes between the two. So let's look at this one, and we see we have 1, 2, 3 carbons, and then we have an oxygen with 2 carbons. Now we need to add our H and our OH, and we're going to add the OH to the fragment on the left and the H to the fragment on the right. Make sure that you don't put the OH group in this spot. We still have 1, 2, 3 carbons, and so we need to have 1, 2, 3 carbons in our product. When you're doing your sapling homework and doing reactions, I find it best if you write them out on paper. Trying to just look at it on the screen and draw the products can be challenging. Draw it out what you have, and then do the manipulations on paper, and then put your final answer in the computer.